problem we faced with this project was that it costs a lot of money to send things to space. NASA estimates that it costs between $5,000 and $10,000 for every kilogram of cargo sent into space. We looked at two different solutions to this problem, with both of them being 3D printing applications. The first was studying how well we can recycle PETG plastic, and we reused the same batch of plastic over the course of 10 generations. The second solution we looked at was reducing the weight of the cargo. For that, we created a new composite material combining carbon nanotubes into a matrix of PETG plastic. The composite should have strength properties closer to metallic materials, but the weight of plastic materials.
The main objectives of our recyclability study was to extrude 10 generations of material, printing test pieces from each generation. Test pieces were all made to ASTM standards, and we conducted impact, tensile, compression, fatigue, and flexural tests. From this testing, we were able to determine how the material properties will change over time. From our composite study, we mixed carbon nanotubes with virgin PETG material. Throughout both of our studies, we used our horizontal extruder to produce printable filament from plastic pellets.
Carbon nanotubes are one of the strongest and stiffest materials known. We hope by adding carbon nanotubes to the PETG, we can increase the tensile strength, allowing for more applications of additive manufacturing. Carbon nanotubes also have a very high thermal conductance, 6 times that of copper. The composite material could be used in heat dissipation applications. Carbon nanotubes are also electrically conductive. We believe in high enough amounts, the composite material will display semiconductive properties, allowing its potential use in electronics. We made samples of 1, 3, and 5% by weight. We wanted to use less amounts to try and be economically prudent with the cost of carbon nanotubes between $1 and $10 per gram, depending on purity size, and if they were single or multi-wall.
On the testing side of things, impact testing revealed that there was significant material degradation from generations 1 to 2, however, there was minimal degradation from generations 2 through 10. The carbon nanotube impact testing revealed that 3% performed the best and 5% performed the worst, due to the material becoming increasingly brittle as more carbon nanotubes were added. Additionally, thermal testing the carbon nanotube composite revealed that thermal conductivity doubled in just the 1% mixture compared to pure PETG.
Isn't that cool? That's pretty awesome. But what about the money? Well, the US Department of Commerce estimates that $667 million is saved every year with additive manufacturing. This is largely due to no longer having to cut, drill, or remove excess material. With additive manufacturing, you're using exactly what you need. As long as we understand that once it's recycled, performs at this lower standard, we are able to continuously reuse the material with little to no degradation, which is a great solution towards zero waste, especially if you're in space.